Good evening, everybody. My name is Andrzej.
Kacper.
And we would like to share the word about the Inkuire tool that lets you browse the Kotlin libraries by signatures of the functions. So at first, a quick bio. We're software developers at VirtusLab. We've been working over a year right now on various projects like Kamil said, dokka, which is Kotlin documentation tool. We're also computer science students of the AGH University of Technology in Krakow. We've graduated about 2 weeks ago, and the Inkuire was our bachelor thesis. We wanted to create bachelor thesis to be a tool that won't be archived like many bachelor thesis ends up. And VirtusLab came with a helping hand and proposed the idea of the Inkuire tool, which we were happy to implement. So let's take a look at the agenda. At first, we will talk about the motivation and goals, why this tool is needed. Then Kacper will tell something more about the how the engine works internally and how can you use it. And at the end, we will have a quick demo session where we would show you how to use the Inkuire and how to configure it for your own library if you'd like to. The first chapter is about motivation and goals, and I will talk about the problems that probably every developer had encountered in their daily work. So what's the problem? The names of functions are not always meaningful, or the amount of possible functions extensions to browse is overwhelming. So I think everyone had this moment when he knew how to implement some function, but he had a hard time coming up with the right name because the name was too long or was not so self-explaining. Also, everyone was working on an external library when he doesn't know the API yet. And for example, iterable interface has over 260 extensions. When as a developer, I received the documentation as a list of these extensions, and there is 260 functions to browse. It could be overwhelming, and you could possibly skip the function you're looking for. So the first example, I have taken the example from standard library of Kotlin. It's very simple function. It takes 2 integers. One is as a receiver and returns a string. It's actually returning the integer in a different number system. The problem is the symbolic name because, well, I could think of a function like containing the name like convert or number system in its name, but toString is actually quite okay. But at first, I would look for a function containing convert word, I think. On the second example, a function called scan. It's quite sophisticated, but it's actually running like a normal fold function, but it actually returns the all intermediate accumulator states instead of the final result of one value. There is also an alias for that function, running fold, which somehow helps, but if you don't know the name and you look for the extensions in iterable, you have 260 extensions to browse. It's quite huge number. So what's the solution for this? Browsing documentation not by names, but their types. So for the first example, we can think of the function not as a function with symbolic name, but as only a signature of type. It can both be a function with receiver or a function with 2 parameters and no receiver. For scan, it is a generic function containing containing a receiver and 2 parameters, or it could be also be a 3 parameters with no receiver function. but writing it as a receiver, it's more convenient probably. So how can we do that? We need two things. We need a semantic data about the source code, and we need a query engine. So how to get a semantic data about the source code? Let's use Dokka. I think many of you are familiar with Dokka, at least with an old version, but I'm not sure. Have you heard about the new Dokka? It's been rewritten by guys from VirtusLab about a year ago and released, and it's a brand new tool with a new user interface. The second thing, which is very, very useful in that case, is that Dokka is possible to have custom plugins developed by developers in a very easy way. So, for example, this is the output of Dokka for some API. So it is very, very easy to make a plugin that will convert the signatures to be Java signatures instead of Kotlin signatures. How can we use that extensionability? As you probably know, such tool needs some semantic analysis of the source code. Of course, we don't need to write the whole parser and semantic analyzer for such case because it's reinventing the wheel. We can use the existing tools, for example, Dokka, which does the semantic analysis by us, and we can just plug in and use the data collected by Dokka to create a semantic database. On the other hand, we need a query engine. Although the idea is quite innovative, it's not the first tool. There is also an existing tool for Haskell language called Hugel, and it is sometime on the market right now. There are many Haskell users who are very happy of that tool, which made us strive to make also such a good tool for Kotlin language. So coming to the example one, this is the final result we would like to have. So in the top right corner, where is a usual magnifying glass to have a search bar by symbolic names, we added the second magnifying glass that gives you a pop-up which lets you browse not by the symbolic name, but by their signatures. So here's example one, and here is the example two. As you can see, there are two matching functions, running, fold, and scan, which proves that that there are indeed two functions like that, probably with the same implementation. So here's a summarizing slide that if we take Dokka to get the semantic data and provide it to the Hugel-like tool, we can have our own tool called Inkuire.
Okay. So by now, hopefully, everyone has a brief idea about what the project should do. So let's take a while to talk about how the engine works and to phrase it in a bit more UX-friendly way. What results should a person expect after inputting a given signature? So in order to find or match rather all the signatures that the user hopefully wants to find, we need to come up with some sort of metric to figure out which signature matches our expectations and which one doesn't. So let's start by building some sort of intuition behind our idea. So we have an example here. At the top, there is a search query, which is just a function on, or rather a method on string, which takes another string and returns an int as a result. So what about the first signature? What can we say about its compatibility with our search query? So the first thing and most obvious is that it has a different number of arguments, of course. So we wanted something that had takes two strings as an input, and so we don't really want something that takes only one. Plus, the result type is all wrong because int doesn't have anything in common with a list of characters. Okay, so what about the second one? It's a pretty straight yes. The only interesting thing is that the receiver is different. Instead of a string, we have a char sequence. But one of the basic OOP aspects of Kotlin is, of course, inheritance. And it's pretty obvious that string as because it inherits from char sequence, it gets to use all its methods. And what about the third one? Well, if anyone can recognize it, it's just a compare to method from comparable interface, and which is implemented by string, or rather, which is inherited by string. So obviously we can use it. So turns out the metric that best describes the signatures, or the set of signatures that we want to match, is substitution. So the question we have to ask for each pair of signatures is if we can use a function, a possible match, in place of a given signature. Okay. So how do we achieve that? The first thing, and again, the most obvious thing, is the number of types. So if we get a search query which wants which has one receiver, one argument, and one return type, we want a match that has the exact same arity. Well, there is an argument to be made about whether a receiver should be treated as an argument or not. So let's treat it like that, because we can use Kotlin methods either with a receiver or not. So the more interesting check we have to make is checking the match of all individual types, or rather pairs of types, if they can be substituted for each other. But the question rises, how do we check that? So if we are checking if a possible match is a good fit for our query, do we check in this case for the receiver if string is a subtype of character sequence, or the other way around? So in order to do that, to figure that out, can we have please the next slide? Thanks. We have to look at the variances. So in Kotlin, we say that the variance of a receiver and arguments is in, which is contravariant, and the variance of the return type is out, which is covariance. So for for our string, we can match any type that is the subtype of our of the type. So in this little type hierarchy that's obviously not complete, but serves the purpose of this example, we can match any type that is in the red circle. And for the return type, we can match any type that is a subtype of a number, so anything in the blue circle. Okay, so that was kids stuff. Probably everyone knows about that. So let's take a look at a more complicated example, which means a more interesting example. So this, we have an example signature, which obviously isn't usable in pretty much any circumstance, but it gives us a good example to work on. So the result and the argument behaves the same way. So we're gonna ignore that for this example. But let's take a look at the receiver. So the receiver is now a generic instead of a concrete type, and we obviously have to match the function one with a generic that has the same number of arguments, and as said before, we have to match it with a super type of function one. But how do we check the arguments? So is it just the way it was with its parent type, or maybe we have to look at something else? So in order to do that, we have to look at the function definition in Kotlin standard library. It states that the first parameter is in the context in, which is contravariant, and the other parameter is out. Okay, so we have something like this. We have, for the interesting part, we have a function one, which is in context, a number which is inside an in context, and another in context, which comes from function one, and a long, which is in an out context, which is inside the same in context. Well, this doesn't really tell us anything when we look at it in the Kotlin syntax. So let's take a look at what it would look like using Scala. So Scala changes the syntax with replacing in with minus and out with plus, which really isn't that convenient for everyday use, but it serves a purpose here because there is a simple rule we can apply to determine how to check our type. To check if what matches should number accept here, we just have to multiply all the context it's in. So we multiply minus by minus, and we get a plus. And to check to get what checks we have to run for long, we multiply minus by plus, and we get a minus. So in our type hierarchy tree, or rather a graph, it will look something like this. So for a number, we once again only can match the subtypes, and for our long, we only can match supertypes. Cool. So that's pretty much how the engine works on, let's say, pretty basic examples. So how can I use it now if I know what to expect? Well, there are two ways. The first one is a REST service which is written in Scala. And we also have a global instance for it, which is accessible at the address at the bottom. The second way to use our search engine is, as Andrzej previously said, by using the dokka plugin, which embeds a little widget that basically looks like this and lets us search Inkuire inside of Dokka. It uses the same implementation, and it is transpiled to JavaScript, so it runs directly in the client browser. We also did some tests the first one is the REST server, which runs on JVM and takes around 300 milliseconds on localhost to find to finish a query. And the second one is JavaScript widget, which takes around a second because in the query time we have to account for the debounce time in the input. That poses the most important question today, which is why am I showing this table? There are two reasons. The first one is we want to show that the engine and the whole Inkuire project is usable. So maybe traversing the whole type system doesn't seem that fast, but it actually works pretty well. And the second, more maybe important reason is that obviously the raw data says that JavaScript is almost 3 times slower, and a JS joke is always funny.
Now I will show you a quick demo how to use our tool. Let's go to the instance of our dokka generated for standard library. I hope you're familiar with dokka. If you're not, I strongly recommend go to dokka GitHub and check this out. Of course, it is built with our plugin attached. So let's run it. Oh, it's an old query. So let's try to find the toString from the previous examples. Yeah, it is here. So we can just jump to the documentation. Here is aggregated all toStrings with the common signature. So integer is below here somewhere. But yeah, you can already read the description for the function. Let's look for the scan function, which I mentioned before, but we will use the knowledge that Kacper shared, that we can use also the different types. In the scan, the signature has iterable as a receiver, but we will use list because we're not sure what we would like to expect. So let's try that one. And as you can see, here they are running fold and scan, both have the same signature. So probably they have same implementation, or if you're not sure, you can also jump and try to figure out from the example and the description. I think we all know what will work for the different cases. I will show one more example for example, applied signal types, partially applied. So let's try to find the map function. So it's something like that. And hopefully you find map and map.null, since map.null is weaker because of the this function could be also used in the nullable context. So I think you can you have a basic sense of how the tool works. I will show you now how to configure it for your own project. So let me change the screen. Okay, so as you can see, there is a simple project, a very basic project. I just generated hello world for the Kotlin. Just added my class and my function. So what to do to have Inkuire in your own project? Let's go to the build Gradle. The first thing you need is the dokka. The configuration of dokka has never been simpler than now. Actually, to have a minimal configuration, it's just add to the correct plugin and the JCenter. The more information about configuring dokka you can also find on the dokka GitHub repository. So when you have a dokka created, you get the variety of the dokka task. For example, dokka HTML Gradle task that will generate the documentation for your project. And to get the Inkuire as a plugin, you just need to add our Maven custom repository, and in the dependencies block, you just add the configuration for dokka HTML plugin with the correct with our artifact coordinates. So if you generate the documentation by using dokka HTML task, you'd probably end up with the generated documentation with our tool installed. But there is one catch. As I said at the start, there is we use dokka to analyze Kotlin sources. We document the sources and not the dependencies. And the problem is that the problem that also Google encountered was how to sustain the types hierarchy when you don't have dependencies. And the only possible solution is to recursively go to your dependencies, then generate their types hierarchy, and go to their dependencies as you reach the bottom. So for bigger projects, it can be problem to go to every dependency. We have only a dependency to standard library. So actually I had to add the types from standard library as a database and add another entry for the database of types of standard library in the JSON. The more information about configuration you can find in the README section of our GitHub. So when we come back to the presentation. So here is the documentation generated for our little library. As you can see, here's my class with the function, or my function, it should be my function. So let's look for it. My class, it receives int as a parameter and returns int. And here it is, mu function. So it will work for of course, other classes and functions, as you can see. So, here's a link. You can find minimal configuration I just presented on my GitHub, or you can go to VirtusLab Inkuire, where it's also explained everything in the README section. So what about future releases? The first one is multi-platform, because Inkuire right now, although Dokka interprets it's multi-platform and returns the collection of databases respectively for each platform, the query engine is actually single platform, so you have to decide which platform would you supply to the engine. The second thing we've been thinking of is whether we could just analyze the jars from class path. We're not sure yet because the jars are compiled, and I don't know if we can get all the semantic information that we need and we obtain from the source code, but we're also considering that, and it would really improve the experience because you do not have to go to the dependencies manually. It would be just a single run. The third thing we consider is support for Scala-free inquiry engine. And we're looking for your feedback. If you'd like to report the bug, because there might be some bugs in the engine, or if you have any proposal, you can reach us at the VirtusLab/Inkuire repository and file an reissue. So that's all. Thank you for your attention. And if you have any questions, please don't hesitate to ask.